Stars like the Sun can become remarkably photogenic at the end of their lives. A good example is ngc2392, which is located about 4,200 light-years from Earth. ngc2392, which is nicknamed the Eskimo Nebula, is what astronomers call a planetary nebula. This name, however, is deceiving because planetary nebulas actually have nothing to do with planets. The term is simply a historic relic, since these objects looked like planetary disks to astronomers in earlier times looking through small optical telescopes. Instead, planetary nebulas form when a sun-like star uses up all of the hydrogen in its core, which our Sun will in about 5 billion years. When this happens, the star begins to cool and expand, increasing its radius by tens to hundreds of times its original size. Eventually, the outer layers of the star are swept away by a slow and thick wind, leaving behind a hot core. This hot core has a surface temperature of about 50,000 degrees Celsius and is ejecting its outer layers in a fast wind traveling 6 million kilometers per hour. The radiation from the hot star and the interaction of its fast wind with the slower wind creates the complex and filamentary shell of a planetary nebula. Eventually, the central star will collapse to form a white dwarf star. X-ray data from NASA's CHANDRA X-ray Observatory show the location of million-degree gas near the center of ngc2392. Data from the Hubble Space Telescope reveal the intricate pattern of the outer layers of the star that have been ejected. Taken together, these data from today's space-based telescopes provide us with the spectacular views of planetary nebulas that our scientific ancestors, those who thought these objects were associated with planets, probably could never have imagined.